So yeah, I'm Sam Hulme, and I'm one of the PIs. So my job is to take the data from the Sentry team and interpret it, make maps of it, organize it all into a project that we can integrate with where JSON is, what samples we take, what our results are, and ultimately have a final project at the end of the cruise that summarizes all the activities we do we're on Sentry and JSON simultaneously this whole time. We have sort of a tentative idea of where we want to do our first JSON dive, which actually at this point Dorado has never been dove on. The best map we have was taken 15 or 20 years ago, with technology where all it really is a bump on the map.
Right.
So we have no real concept. I mean, one side looks steeper and the other side looks less steep, but we really have no idea what Dorado looks like.
So this is really exploration.
So right now, the first thing we'll do is we'll use the ship's multi-beam, which actually it's an EM-122, which is the best deep sea multi-beam system there is on the market right now. So just passing over it with the ship, we're going to get a map that will be 10 times better than our existing map before we even dive with Sentry. So right at that point, we'll first start looking at it and say, okay, well, we're going to send JSON here based on the data we get from our first pass. So right now our goal is let's get the data off of the ship, clean it, process it, and make a picture as fast as we can to start planning our first dives. So we're kind of going out semi-blind, just kind of a foggy idea of what this place looks like.
Okay, so when we go out, is that when we start to look for where we want to put JSON down, or is that we already know the first spot?
Well, no, we really don't know.
So that's what we're looking at right now.
So it'll take us, it's 100 miles out,
right,
and then we'll survey another 100-mile
with the ship.
Yeah, swath.
Okay.
So our survey, first we're going to pass over where we're going, and then we'll start processing the data. So the idea is by the time we're done surveying, we'll have a picture. And we know where Dorado is. It's not that big. It's only a couple kilometers across.
Oh, okay.
So we'll be close enough, but we don't know the exact spot where we want to dive until we see these first images coming off of the ship multi-beam.
Okay.
And the ship multi-beam, it has, you get depth, but it also has a backscatter capability. So the sonar records the intensity of the signal coming back. So even with that shipboard multi-beam, we'll be able to see where the sediment stops and where the rock is and things like that. So we'll be able to start planning, our JSON dives as soon as we get that shipboard multi-beam, which is typically as good with imagery as you get out here.
Okay. So really simply, can you tell me, like a topographical map, this is way different than that, right?
No, it's not at all.
Is it more detailed than that then? Is that the beauty of it, or?
It depends what you're talking about. I mean,
I'm thinking about the old ones.
like satellite altimetry, that you could now from USGS is 1 meter resolution.
Okay.
But with satellites and optics and radar, you're talking wavelengths on millimeter scale or bigger. With sound, you're talking meter scale wavelengths of sound waves, and they're slower, and you're slowed by the time the sound goes down and back up, versus the satellite and air, it's all the speed of light.
Right.
So it's orders of magnitude different resolution that you get in the ocean versus on land.
Okay.
But compared to old sonar, or let's go the other way. Let's see like the Google Earth map of the ocean. That map mostly is on, let's say, just 500 meter blocks. So that seamount that you see on Google Earth in the ocean, they know, okay, 500 meters square, this is kind of what it looks like. And some of those seamounts we survey with better sonar, and they're not even there at all.